Good morning, good afternoon, good evening. Welcome to EIG's sixth in a series of webinars focused on a path to smart warehouse, digital twins, and automation with our guest panelist, Hosni Adra from CreateASoft. He's a CEO there. This founded in 1992, and he's calling from Aurora, Illinois. John Cosgrove, founder and CEO of Atlantic Handling Systems, founded in 2005. And he's from Fair Lawn, New Jersey. And then there's Dani Kaplan, founder, ERP expert of SMC Data, founded in 1980. He's got us all beat, from New York City. And then I'm Jim de Vries, founder and managing partner and master integrator of over 80 partners of Enhanced International Group, founded in 2016 here in Bethlehem, Pennsylvania. We appreciate you taking the time today to attend today's webinar. In evolving a resilient enterprise, especially in this VUCA world. EIG has over 130 webinars up on our website and on YouTube. You're welcome to look at those and review them at any time. Again, this is the sixth in a series of webinars. We started off by looking at maximizing production and warehouse capacity from a real estate perspective. We looked into financial investment with Josh. And then we got into digital twins a while back with Hosni. We're having a different twist on it this time, more integrated approach. And then we also got into AI vision systems with Nile Parekh from Arvest. And then our last webinar was with Gary Marks on site selection. So we're very pleased to be here again today to talk about smart warehouse and AI digital twins and automation. And next month or in 2 months, we'll be looking to do another webinar on GDP growth or some other topic. We'll have to come back to that. Again, thanks everyone for joining. Please enter any questions you have in the chat throughout the webinar, and we'll get to them as quickly as we can. We'll get right to the deliverables today. The deliverables first, we're creating a path, a clear path to increase productivity. That's our number one deliverable. Then we're looking at controlling overhead, on-hand inventory and allocation, whether it's overage or not having enough or shortages. We're looking to manage that bullwhip effect that's going constantly. So 6 months ago, there weren't enough warehouses. Now we have too many warehouses. So we just keeps going up and down, oscillating like crazy as we are living in this VUCA world. So how do we capitalize on that? Then we're going to get into properly using AI to benefit operations. 80–90% of all implementations fail of AI. And these are the implementations that don't fail. That's what we'll be talking about today. And we'll do that through 3 proven technologies perspectives, from an ERP perspective, from a automation perspective, and of course, from the digital twin perspective. And we're showing you that cohesive grouping today. And then we'll have case studies interlaced throughout the webinar. So I'll just give a brief overview of EIG. Again, we're 80 partners, covering people, process, data, and technology. We focus on 90-day return on investments, not to exceed a year, and very quick implementations, and implementations that do not cause disruption in your facility and in your supply chain. That's what we focus on. Again, today we're focusing on digital twins and AI. With that, I'll turn it over to John. John?
Yeah. Good morning, everyone. I want to thank Jim for the opportunity to be part of this whole series so far. Atlantic Handling, we employ over 135 people between our parent company and Atlantic Handling. We've been designing all types of material handling equipment for over 40 years. We provide a CAD design team for building layout requirements, in-house project management group, a broad representation of many fine manufacturers, and we have experienced installation crews, and we work very well with our partner Dani Kaplan, who is at the VAI software, and with Hosni and his simulation and his digital twins.
Good morning, everybody. Thank you for coming. I represent VAI for the past 25 plus years. It's a single database software that has manufacturing, distribution, food, pharmaceutical in it. Single database. There is no need to have multiple software that can create integration issue. VAI has 200 employees, 5 locations nationwide, support 24/7. And 90% of the 200 employees are technical people. Training is being done on site, and after you go live, the technical team and support team stay on site until they ensure that everything is working well.
Thank you, Jim, John, and Danny. Thank you, everyone, for joining. Hosni with CreateASoft, and we started CreateASoft back in '92 with the vision to create an environment that's easy to use for everybody on the simulation side. Around 2011, we decided to switch and start doing digital twin and integrate AI into it. Of course, at that time, AI and digital twins were not the buzzwords that we have today. So for now, we are providing everything from either inside the four walls, outside the four walls on the supply chain, and any external effect that'll happen on your operation. The solution applies to manufacturing, warehousing, and healthcare. We're going to concentrate on warehousing today, and I'll try to bring in some of the manufacturing aspects to it as we go through. Right, Jim?
Thanks, Hosni. Thanks, Danny, and thanks, John. We look forward to a very interesting webinar today with lots of feedback from everyone. Our agenda today is we're looking at the challenges of leveraging AI and automation in your facility, and then we'll get into the remedies to overcome through this joint venture of our different partners here, and then we'll walk through that solution from consulting all the way through ERP selection with Danny's system and how that works, automation of equipment, and of course the AI digital twin. And then the role of the digital twin will be addressed, as well as benefits and return on investment. And then the case studies will be interlaced throughout the webinar, just to let you know. And then again, let's get started with the challenges. So the way we look at it is there's a convergence, over the last 10, 15 years of operational technology, meaning your physical equipment, your SCADA systems, all of your electronics on the floor and in the warehouse. And then you have your information technology that sits in the ERPs and the business systems off to the side. So somehow we got to get these things to talk to each other. So there are some challenges in that and drivers. So some of the drivers, of course, we're trying to create that efficiency, safety, and sustainability over time. And then there's these legacy barriers that we've had for ever since I can remember is how do we get these systems to talk to each other? And data are siloed. Most ERPs are financially based, not transactionally based, therefore a very big challenge. And then data is controlled within the silos. That's driving that trust and change management challenges that we're all encompassing. So what we want to cover today is how do we overcome these? And so what we put together in this next slide is how to overcome these different challenges. And Hosni will kick us off with it. Go ahead, Hosni.
Yes. So a lot of times you go into these operations and the first complaint you get is that I don't have data, or I don't know where the data resides or how it works. Everybody has data. The problem is the data itself is segmented. Every single location has data in silos. Automation has its own set of data. AMRs and AGVs, guided vehicles, have their own set of data. Your WMS and ERP has its own set of data. Then you add to it RTLS and other IoT devices. So all these are segmented within the operation. They don't talk to each other most of the time.
Danny?
Many companies are facing today the issue of supply chain issue. Prior to COVID, supply chain, the inventory was plentiful. People call the vendor, give me the best price, drop ship to the warehouse, drop ship to the customer. Today's a different reality. The cheapest vendor is not the best vendor. It's a question of on-time delivery. Late delivery creates production disruption. Over time, you can pass the cost to the customer, or the cancellation, warehouse space issue, and cash flow issue. So having real-time information of the inventory, customer purchasing, and the vendor supply the inventory is essential.
And then we look at it from a change management and workforce readiness perspective. This is always a challenge is when you're putting in a new system is getting the workforce ready to take that on. And that onboarding process is crucial to make them part of the process and not make them external. So the change management for implementing these technologies is essential for successful deployment.
Unclear ROI and business case. 69% of warehouse managers see a return on investment within 1 year of implementing automation, but only when integration is done correctly. Without clear KPIs, projects stall in the pilot mode and fail to scale.
Thanks, John. And as we know, everybody's automating, yet only 65% have an increase in automation budgets. So there's a lot of stagnation out there in making decisions to drive automation in the facilities. And on top of this, 80–90% of all implementations fail in the AI world, just like back in 2005, the same percentage were failing. And why are they failing? Because they're not looking at it from a people process data perspective before they implement the technology. So with that, we want to just socialize a little bit about what are your challenges in moving to Digital 5.0. We kind of outlaid some of the challenges we've seen. And I see here system integration, stakeholder alignment, leadership commitment. So John, any added thoughts on this?
Yeah, what the whole crux of this webinar is about is that the joint venture of Jim doing consulting up front, followed by Dani's ERP and WMS, followed by my automation and Hosni's verification of that. And that's how we integrate. When Hosni does the digital twins and AI and simulation, he's verifying that the return on investment will be there on all the other components that Jim, myself, and Danny put together. So the integration is crucial.
Thanks, John. Hosni, your thoughts?
You're muted.
You're on mute.
A lot of these are very common issues that a lot of companies face. Our combination of the partnership that we have with the group basically allows us to overcome a lot of these. Everybody in the group is an expert in their own field, but as a team, we provide the full solution that is required to overcome a lot of the constraints and a lot of the issues that companies face.
Danny, your final thoughts?
Integration is essential. People often make a mistake that buying a standalone warehouse software along the ERP, and then you create integration issue when there's an upgrade on one of the modules, and then each vendor blame the other. Having a one-stop shopping like we have here resolve the issue because it's all integrated like a smooth transmission in a car and the engine. It's very important to have smooth integration.
Nicely said, Danny. All right, with that, we're gonna please keep entering in your challenges either in the chat or in this Wordle. And at the end of the webinar, we'll review them and look for some comments. So with that, some remedies that we are using to overcome this through this joint venture of us. And this is kind of this is outlined in our path of optimization to achieve Industry 5.0. And we're really focused on these first 4 blocks here. Gary Marks was helping out here too. Actually, from a site assessment, even before the wells are put up, you can put the digital twin in. The digital twin goes from being hypothetical throughput all the way through actual throughput. Of course, we're speccing and making sure any changes to the current facility or future facility have a proven ROI. And then we're collecting all this data through the VAI ERP. And we have other systems that we won't be talking about today. And of course, we have a full suite of AI LLM tools to support this. And of course, operational excellence and change management. With that, I'll have Hosni kick this off on how it all flows together. Hosni?
So it all starts with, the idea of having either a new facility or modifying an existing facility, whether it's a greenfield, brownfield, or an existing implementation. You take the model, you create a digital twin, as we will see here shortly, and then that digital twin will progress all the way through the implementation phase. It'll validate how ERP and the WMS actually work and make sure that it works correctly on your operation. It verifies that automation is implemented correctly. It helps the automation systems actually create the logic that they need to get maximum efficiency. And then it goes even to the next level where it goes real time and has a life beyond the initial implementation. So that's when it becomes a real-time optimization tool with the help of AI and the digital twin.
The integration between the ERP and the digital twin and the warehouse is essential. Having a seamless introduction is priority, ensuring that the data is accurate. And having the information create a smooth transition of finding the information in the warehouse, upgrading it, and shipping it out to the customer.
So when you look at the AI solutions or the digital twins, what happens is Hosni can recommend to me what automation requirements are. Danny's WMS is the intelligence that drives my system. And then we install the controls that will take care of the conveyor system or any other automation you might have within the warehouse. We can maximize the storage. And of course, today, high density space utilization is a must with the cost of real estate.
So as you can see, these are all aligned to your facility to provide you that closed loop optimized layout inflows. Danny, you want to?
This
Sure.
is the high-level overview of the VAI system I represent for 25 plus years. It has manufacturing, distribution, warehouse, CRM, analytic mobility, all in one-stop shopping, eliminate the need to have multiple vendors and multiple integrations.
So the intelligent design to increase productivity. Of course, automation today is made up of conveyors where we can actually bring the work right to the pickers, or vertical lifts, which will use high density storage in a small footprint to help you do that. Sortation at shipping and receiving, which also alleviates will help you with people. Slotting, which is, if you're looking at the drawing to your right, these are pick modules with tri-width conveyors down the middle, which is a very, very, very useful component when you're doing e-commerce or anything like that, and picking and packing. And of course, we integrate our controls with the WMS, which can tell us what the box should weigh, what size box to use, so on and so forth, which once again increases our throughput.
Thanks, John.
Okay. So what you see here, we're going to walk through the solution: consulting, ERP, WMS automation, AI digital twins. On the right, you see coming out of a pick module is a spiral conveyor, which takes up less real estate within the warehouse and helps you to bring cases down from that have been picked on the upper levels. This is a case study that we had done. It's a leading cosmetic and beauty aid manufacturer, and they're located around the world. What they do is they came to us and they had a problem with they were applying UCC 128 labels by hand, and in August they would bring in 30 temporary employees, and we had to come in and help them to do that. And if you go to the next slide, Jim, I'll just show you real quickly what we have. If you look at it here, we start with an ergonomic lift table, which prevents back injuries and so on and so forth. And then they would load each case onto a zero pressure accumulation conveyor. And what we do is we gap the cartons so that we can bring them into a print and apply, where we apply 3 different labels that were required by their end users. We run them through a barcode scanner to check and make sure that the placement of the labels are correct, because that averts any fines that might be issued against them. And when problems are found, we have what we call a reject lane. If it's a bad read, we'll send it down the reject lane. And then all cases are sent down and sorted and loaded onto pallets for shipping. This was rated by this specific Shiseido Cosmetics as the #1 project in the world, actually, and they won a big award for it because we eliminated 30 temporary employees. They were doing about 800 cases a day, and when we got the system in, they can do 5,000 a day now.
Amazing, amazing, great story, John. So next, we want to get into the role of the AI digital twin, and just want to start. In any manufacturing facility, you might have a CNC area, you may have a milling department, you may have an assembly area, but behind the scenes, you have all this data for monitoring, planning, data storage, batching, planning and outsourcing, warehouse data, and you have your ERP. So just wanted to show this diagram to say what we were doing is putting like a wrapper, I call it a wrapper, on top of everything, where we're pulling all that data from the MRP, the MES, the SCADAs, your Internet of Things, into centralized data marts, into BI. This is a traditional thing that most companies are doing as part of Digital 4.0. But what we're doing that's different is we're putting that wrapper on top of a real-time digital twin that allows us to do SINOP live, because the data in the digital twin from CreateASoft is actually updating in real time. And Hosni will explain a bit more about that. Hosni?
Thank you, Jim. So before we go any further, let's just make sure we all are in agreement of what we call a digital twin. A digital twin is a true representation of the live environment. It's not a pure simulation. It's not a visual representation. It is an actual plant or warehouse that works exactly the same. It's dimensioned exactly the same as the actual warehouse, the actual facility. It has all of the components that you have for all the materials that are flowing through, material handling that you have in it, the people, everything that runs within the live environment is in the twin. So this is not an approximation of live. This is as close to live as you can be, within 99% plus accuracy throughout the operation. Now, this is also giving us a path to go to AI in real time. As you will see here as we go forward, having that specific data set will allow us to have more productive insights and more accurate insights on what's happening, what will happen to the operation. So if you look at any smart warehouse, you definitely have a WMS and ERP like Dani's system. So this is going to control everything that you have within the data itself, as far as what's going into the warehouse, what's coming up. So this is your receiving, your replenishment, your put away. A lot of these systems have some kind of a slotting environment built into them. They have a scheduling system that's waving or providing data into the actual warehouse itself. So all this is going to drive what happens within the warehouse itself from an ERP. In some occasions, the ERP system and the WMS can actually send data to the automation, like in John's system in this case, where it will help, it'll tell the automation what type of labels it's going to print in this case, what type of machine is going to print, what color. All these will become components that will be driven from the WMS into automation that John has built. Now that automation goes beyond just the print and apply, right? So it goes into every single divert that you would have within the warehouse. It'll go through where you slot, how you move in the pick mods. All these become part of that integration from the WMS to the automation system. So you take all this stuff together, and there's a lot of data between them. Keep in mind in this specific implementation, all the products have different sizes. Some of them are clothing material, some of them have weird shapes. Some are just pure boxes that cannot be crushed. So there is a lot of limitations on what you can do within that. So this is where AI comes in. Now we can put in all these rules into an AI system that is properly trained, and it will start to identify better where do we slot things, how do we do our put away, when do we replenish, all these key things that are required for a daily operation that tie in the automation of what's happening live and the future of the operation and the demand planning that's coming from the WMS. So it puts all this stuff together, and now it starts to operate the warehouse in a much more efficient way.
We got a question here, Hosni.
Sure.
So are we moving from having collecting information on what people are doing to telling people what to do? Is that the flip that you're working on, or are we recording what people are doing? How does that work?
So we will get into the recording of the people. Initially, we have the data that's available very readily by everybody. I mean, everyone has an automation system that produces a set of data, whether it's coming from the PLCs or it's coming from different control systems that is collecting that data. And then you have the ERP and the WMS that has the demand and the receiving and what I need to ship and what I have in the warehouse. Now, as you go forward in these, there will be, if you want to skip to the next slide, Jim. So there will be additional data components that you will go in regards to people. And this is where everything that is scanned, every movement that you would have, your automated guided vehicles, for example, your fork trucks that are moving around, the person that's picking things from a pick to light system, all these become data feeds that you will send into that digital twin. And keep in mind here, the more data you have, the better the twin is going to behave, the better the twin is going to learn how your operation works. But as we talked before, that data already exists in your systems, right? It just segmented into different silos. And what the twin is now doing is combining all this to provide that view of the warehouse that is complete. And it's using that complete view to plan the full operation. So if we go to the next slide, so a lot of times you would have additional data points. Some of you are using IoT devices to track things. Some are using RFID or GPS type devices, or some other components that are providing data from the real world system. These are crucial. If you have those, they definitely have to be funneled into the digital twin, and that will give you the current state of the equipment. So this will tell you how many guided vehicles you have running, how many operations, how many AMRs are running, when do you actually need to charge. All these different things that will occur within the operation become now integrated into that digital twin. So John, I want to just go through some of the automation.
Yeah,
and-
if you take that back, Jim,
So-
to that slide.
Sure.
Okay, so what you see here, where the shelving units, that is a 3-level high pick module, which you see at the top left corner. And then we're running it through a print and apply, which is the bottom picture. There you can see we're running conveyor through there, and then it comes off that spiral from the top. So some of those, and the simulation is a great way to back up what we're talking about as far as validating what the system will do and like how many cases we can do a day or an hour, so on and so forth. You know, if you look, they're running them through some scanning tunnels there and so on and so forth. So the automation we get to put in with shows fork trucks with put away. It's all being analyzed by the digital twin constantly to give us a solution, real time.
So these are the pick modules here, right?
Yes.
That's correct.
Yeah. Yep.
And so this is
That's just showing that's some transport conveyor that's going down to a sortation and a load. But as you see, when they're coming through, they're going through a scanning tunnel, which will tell them where our controls will tell them where to go with that.
awesome.
That data is coming live from all of the different data systems. It's being visualized on either on the web or on your desktop, along with all the metrics that come out from that and identifying what's going to happen in the future based on the current state and all the information that is collected up to this point in the warehouse.
So Hosni, just to let everyone know, on that bottom left-hand picture, that's also a cosmetic company that we did a print and apply for. But if you look, it's hard to see. What we did there is we have a overhead conveyor, and we bring the cartons in from a carton erector on an overhead conveyor, so it doesn't take up a lot of space within the pick module. So it's just a little something that we do to try to make it more convenient and make it more efficient.
So there are some questions in the chat. I don't know if you want to get to them, Hosni, or
So there's a question on what's the definition of the digital twin.
Yeah.
So in my opinion, a digital twin that is purely visual is just a visual representation of the plant. It doesn't really give you any operational value. It gives you a representation of how everything will fit together, whether you have the proper layout, from a spatial representation aspect. What we're talking about here is a digital twin that is pure, that is in addition to the visual, it is operational also. So it does have that additional factor to it. So you can definitely just stop at the visualization aspect of it, but you will get half a solution basically.
that leads very well into building out a
Right.
digital twin.
Exactly. So as you're building the roadmap here, you basically start, there's 3-step process to get to that real-time implementation. First, you start with a model build that actually building initially, believe it or not, that visual representation. And then you start to add the constraints to the model. So these constraints actually apply to different aspects of it. Then we transition to what we call the analysis on the optimization and actual loading of your data set, looking at historicals and try to load and train the AI engine. And then you go to the 3rd step where we turn this thing live and we turn the regenerative AI because the system constantly learns as the operation advances. So this is where you get the full real-time implementation. From an ROI perspective, you start to achieve an ROI basically in phase 2 is when you first see your initial ROI with that. Now, with an average size operation, you're pretty much looking at a 90-day start to end implementation where at the end of the 90 days, you are generating an ROI that a lot more than what you invested in that implementation in the digital twin initially. Um, and that's really, it's using data. It's not using ideas or concepts. It's actual data fed into an AI that's validated through the twin before it is provided to you as a solution.
Yeah, just to build on that, it's the actual distributions. If you're a stat person, you know, a Gaussian distribution is a representation of a process. This is actually using the distribution of the actual process, and as that process changes, that analysis changes. So,
Exactly.
and that is what's unique. Folks are taking the average of an average of an average, and then they wonder why half the time they get it wrong, because eventually that'll get you some improvements, but it's not going to get you sustained improvements as your ecosystem changes, and no ecosystem stays static out there.
So that leads us to the next slide on the simulation side. So this is when you're at the beginning of the implementation, you're trying to validate that the actual implementation has the constraint, it's working. This is what we call a traditional simulation implementation, where you use distributions to validate and test the model itself. Now, keep in mind when you do that, you cannot optimize randomness. So when you put in all these distributions into the what will become the true digital twin, you're just using random data that's generated by a random distribution, whatever that distribution is, and you're trying to optimize it, and you get an optimized randomness of the model, which gives you an idea of what works and what doesn't, but it doesn't allow you to do real-time optimization, and it gets you 80% of the way there. So we don't want to stop at 80%. We want to actually get in 99% plus optimization that will work every single time. So that's where we get to phase 2 of the implementation, where you start to dive into the data itself. We feed the data in, and now we turn that model to be a simulator and an emulator of your environment. So this is where all the constraints would come in, all the size of the boxes, the actual true sizes, the way the pickers are picking, their productivity, their lead time for that specific day, everything that's related to every single aspect of the operation now becomes part of the data that's fed into the system. So with this implementation now, I can validate the logic in the WMS. I can properly identify the logic that can go into the automation from John's system. And then I will be ready to go live with any implementation, knowing that within a high degree of confidence that I will be able to roll this thing out and not run into all of the issues that'll happen when you turn the system on and you have 80% confidence that it'll work. Now you have a 95%, 99% confidence that this will actually work.
So we have a couple of questions here. Can you describe a what if scenario that you would do on a digital twin once it's up and running smoothly? Oh,
so there's 2 questions here that actually pertain very, very good to the slide. And a lot of the randomness that is put in is really not randomness. It's AI generating when that fork truck is gonna fail. Because historically, this is how these are the different conditions that cause that fork truck, for example, to fail. And based on what's happening live, we're feeding that data into an AI engine that has learned all these constraints, and it's going to tell us that based on what that fork truck is doing, it's going to fail in the next half hour, and we expected that the failure will be for 15 minutes, as an example. But this is not something that a distribution is making. This is an actual AI engine that's depicting or predicting when that will happen. And that will go into the real-time aspect where we're predicting the implementation. The what-if analysis will always happen. And as you'll see as we go through, there's a few types of analysis that happen either in the background or where they're requested by a user. And this is where we go into this section here. If you go to the idea of how the failures happen within the operation, that's where regenerative AI comes in. What happened last week could be different than what's going to happen next week. there are all these constraints. So if we don't keep feeding that data and those constraints into our AI engine, we basically stuck in the past, and we go back to the exact same problem that we have today. We're analyzing last year's implementation. So that regenerative AI becomes a key. At the same time, the system in the background is identifying, for example, that there is a downtime. This is a what if scenario that's going to happen. Instead of you as a user going in and saying, I need to run and see what happens if when that machine goes down, the system automatically detects it. It runs the what if, and it says it's expected with a high degree of confidence that this condition will occur. And by the way, this is how you fix it when that happens. So now you're more proactive in the implementation. So instead of constantly running your what ifs, we're letting AI suggest what the what ifs are, running them through the twin, identifying what the potential optimization that's required, and providing them to you on the other side. There is another aspect of it where you actually have a sandbox where I have an idea and I want to test out. This is where you run it into a sandbox mode where you have all of the data. You don't need data collections anymore. You have all the data available to you, and then you can run in sandbox mode where you're basically disconnected from changing the operational value, but you're doing that implementation live. So the idea of what we're trying to do between, Danny and John and myself and Jim is that we're creating that single view of the full operation. You don't need to look at 15 data systems anymore. The data and the analysis and the optimization is all done in one. You have your automation equipment feeding data into the twin. The WMS is feeding data into the twin. Everything is now collected and fed into that AI engine to actually help you run the operation faster. So sometimes you get a 3-4% improvement on a daily basis. And other days, you will get 10-12% improvement. But this is daily operational value that you're saving on a day-to-day basis. It's not a one-time shot where I do analysis, I'm done, and then I move on. It's constantly running in the background and giving you those operational insights into the operation. So this is an example of the system where we have the WMS feeding data on where to divert each one of these conveyors, each one of these boxes. This is the print and apply and identifying the labels. Now, this is what you actually would see on the twin, right? So it's John's system reacting to the data from the WMS, Danny's system providing the data itself into the automation and providing everything else to the environment all the way through. John, Danny, want to?
Yeah, the integration, what's great about it all is the validation. When you if you look at this warehouse and you spend a considerable amount of money on automation, it's nice to know that you can actually see the results real time through the simulation. And then the digital twins will verify that and continue to do that. And there you see some AMRs that are running. You see a lot of those in the Amazon commercials where they're actually taking the shelving units and transporting it to the person as opposed to the person serpentining through the warehouse. But when we do these kinds of things, it's a large investment, and the verification through the digital twins and the AI solution is great. So I think between all of us, between Danny's WMS feeding me what I need to make my controls work, and then the validation by the digital twins and simulation is a really great tool.
Any additional
Excellent.
comments?
Well, just you're talking about slotting. When you build a pick module like that, it might have thousands of different SKUs. So what happens, because the digital twins is constantly evaluating, you can move SKUs around. Some are seasonal, some need more than one facing within the pick module because the frequency is so much, and the twins will help to let the system know that.
So with that, you can actually get a lot of data from the twin and the automation feedback and the WMS and IoT and any RTLS systems that you would have. So these are all things that you can run on a what-if basis, or you can let the digital twin run for you if it's running in real time. So these are all different aspects and different questions that people would ask on what if I do this, and what would happen if I change something in the WMS, or I want to get in different types of guided vehicle, for example, to run through. All these are aspects that you can always run, and you can always run them in that sandbox, or you can let the twin figure out what is the best optimum solution for you from that point of view. So, operational, the very common questions for warehouses: how many pickers do I need tomorrow to be able to run the warehouse and pick and deliver on time? Another question is, what happens if there is a snowstorm coming in and it's predicted to come in the next 3 days? How do I mitigate that in my warehouse so I don't run into delayed deliveries for my operation? So these are things that you can start to apply either inside the four walls problems or outside of the four walls. And then you can all tie that into your cost of unit, cost to process an item. That cost of unit becomes a key component that you can track on a minute by minute basis, basically, all the way through the operation to see how it varies.
Thanks, Hosni. So we're going to just dive a little bit into the ERP, WMS. Danny?
As you can see, in the integration issue is a crucial piece of having the WMS with the ERP, with the twin, and the warehouse. If you have separate island, separate module of a ERP, one vendor, warehouse, another vendor, you have integration issue when upgrade happen. The integration create a broken link, and the broken link will create a domino effect of business disruption and data inaccurate. So having the one-stop shopping you can see here of everything integrated together makes a very smooth operation, and the data is very clear and accurate. I can't stress enough how important it is to have the warehouse integrated into the WMS as a one-stop shopping. Otherwise, when there's an upgrade, you have multiple vendor, and if an issue happen, AT&T blame Verizon, Verizon blame T-Mobile, and T-Mobile blame God. In the meantime, the inaccurate information, which affect the domino effect across the board, the twin and the warehouse. This is a picture of a warehouse automation. It has heavy load, what to pick, when to pick, how many trucks you need. When the trucks leaves the facility, become a GPS, have cold storage, and got the award as a top warehouse in the country. It does everything Manhattan Associate does with a fraction of the cost and less complication.
All right, so just a couple of questions I want to address here before we move forward. As you know, one of the questions is, can the digital twin actually predict and simulate what will happen in the future? That's exactly why we're doing it, is to actually basically have it a predictive tool with a high degree of accuracy to tell us what will happen and how do we actually modify the operation proactively so that we minimize the impact of that disruption. Now, keep in mind, this could be applied to a number of different operations. It doesn't have to be a warehouse. It could be any manufacturing setting. The question is, can it be applied to a cement factory? Absolutely, it can. Actually, we have examples of that I can share with you offline. And as far as connectivity, this will dive actually into this one. we have a number of messaging that goes through a number of connected systems or connected APIs or JSON connectors that will allow the system to either consume data directly from the WMS or provide or consume data from the PLCs or IoT devices. So we have built a large library of connectivity systems to allow us to consume a lot of the data coming in. We also will be able to send data out, provided that your IT infrastructure or your IT department allows data to be fed back into your WMS. With Dani systems, it's different since we already have the integration, but with other WMSs, some are very critical on how you send data out to them.
Just so everyone knows, Hosni mentioned the PLC. That's my part of the technology. We do the controls, which tell the boxes when to divert and what to do with them.
So the question is the 90-day process to get an ROI. Does it apply to a greenfield or does it apply to an existing operation? Actually, it applies to both, because as you're designing your greenfield, you're saving money initially by designing it correctly. So you may not get since you're not running the operation, you would think that the ROI is not there, but the amount of savings and you have achieved basically at that point is generated once you turn the operation live. So this is when, instead of running with an operation that has a lot of issues, a lot of problems, now you're running an operation with very minimal problems where you know what will happen with a very high degree of confidence. So it may not be an ROI that is that you can see very quickly, but it is actually within the operation itself, within the full implementation of the twin. So this is basically how you let data make a decision. We're not using a person's gut feeling or I think this will be better. It's actually data talking. It doesn't have an ego. It doesn't care whether you like the solution or not. It just assumes that this is the solution that you need to give you the best outcome possible for the operation. So this is another thing that kind of like to touch on is the ability to scan. If you are running into a building that you don't have the drawing for, or it's an old environment, or you really want to have a better view of how you lay things out in a greenfield environment, we now have a capability to actually go from a point cloud, from a 3D scan, all the way to a digital twin automatically. So with minimum interaction from the user. And that will transition basically into the warehouse that you have. So if you do scan the warehouse, it's going to tell you if the floor is flat, if you need to grind different areas so that the guided vehicles are not going on a roller coaster. All these become part of that output of that digital twin transition from a cloud system. So this is going into that, basically the AMR. This is just another implementation of what you could have. And these are just guided vehicles. There is a lot of people actually working here. And a lot of the problems that we would see is automation and people are not very well in sync. And this is something that John probably runs into all the time is I need to make sure automation works with people because we're never going to eliminate people from any of these locations. We can minimize, but we cannot eliminate. And everybody who can basically have a better outcome, and it will tag in the fatigue factor of the person to identify who's going to do what and how things are going to move. You can control automation, but you cannot control everything else within the system itself.
It all comes down to productivity. We're giving the people a way to become more productive and to help them and support them in their efforts.
Okay. So just some sample data. When you look at optimization, you can identify what type of optimization you always want to run on a half-an-hour basis or an hour or a daily basis. It can automatically reslot and rearrange what's in the pick mods for you, for example. It's going to tell you whether you're going to benefit from that reslotting. Keep in mind, this is it, since it doesn't have an ego, sometimes it says, no, you're doing actually a good job and there is nothing to change. So that actually will happen in some cases, and it's going to show you the variations all the way through. This is all automated systems running in the background and generating that data. It's going to compute all of your ABCs and your variability of the products in real time. You don't have to do that anymore offline. It's going to show you the variability, specifically if you have seasonality within the warehouse. That variability in demand and in shipment is going to drive how you slot. So instead of very quickly changing your warehouse from one season to another, that AI engine is going to help you transition slowly from between seasons so that you don't have that problem as you go through. Go to the next slide. And then a lot of times, just one thing I would add is there is the productivity of the people that came in, that LMS that's tracking productivity of everybody within the operation. That's all built in, since we have all the data basically from a digital twin perspective.
Yeah, there's a question here. How do you connect to the WMS with a digital twin? There are hundreds of transactions per minute. What type of messaging do you use? Did you answer that question?
Yeah, I mean, that's very common. Depending on, again, what type of WMS you have, we can consume data at a very high rate. We're receiving SAP data at thousands per minute in some cases, and that's not a problem. We receive it, it's processed in the background, and it's basically handled in the system. Keep in mind now, when you can't put this on it is an on-prem solution, so you cannot just put it on a very slow server and assume that it's going to handle the load. So that server that you put it on is going to be powerful enough to be able to support the operation that you have.
Thanks, Hosni. And Danny has a case study.
This is a typical case study of having multiple ERP system. This is a very large manufacturer, distributor in Long Island of pharmaceutical equipment and has multiple systems. It created integration issues, having multiple systems, and the result is the challenge was how do you put everything together? Because having a distribution module and manufacturing module that did not talk to each other very well, resulting in severe integration issue. And those are the benefits of having a single database software that has manufacturing and the distribution part of it. It eliminates all the issues above and has the analysis of the financials, the inventory, the purchasing, the forecasting. In today's reality, it's crucial because you never know when your inventory will come in and who to come from. So that's a major issue to keep in mind. Integration into the twin or the warehouse or between system. It's crucial to have integration.
So this is where it's a complete solution. It helps you create the digital twin. It helps you get all the way from a greenfield all the way to a fully operational with the different type of flavors that we have for the implementation, whether it's creating the twin, performing the actual operation through the construction, all the way to live when you turn the operation live and connect it to the full supply chain of the operation. This is our design, build, and operate sequence.
So with that, we'll just move over to the benefits and kick it off with John.
Yeah, when we automate, we can increase the workforce efficiency by 10 to 30%, reduce your labor costs 5 to 10%, increase productivity up to 30%, enable better accuracy, higher throughput, and of course, space utilization is so key today with the cost of real estate.
One of the issue of not having integrated ERP and WMS is integration issue. But having it integrated together, you eliminate chargeback of wrong product being shipped, get better control of the inventory, which is crucial today, because if you don't have the right inventory, production disruption, order cancellation, and labor cost. You need to know what material you have in stock now. I compare it to a checking account versus a bank account. It doesn't matter how much you may have in the bank, how many checks you already don't clear the bank. Same goes for inventory. What's your net inventory after you allocate for production of future orders? You need the RF device, with today's labor issue, it's a major issue. A smartphone, $400 phone, replace a $4,000 gun, and it eliminate the need for training. And the integration is seamless integration because the warehouse and the ERP is together. So you have completely integration. And one thing about it, having system in the M&A world, if you have multiple ERP, one house is overstocked, the other one is understocked, and you have integration issue and inventory issue. Single database software for manufacturing distribution of food eliminate the issue of having a integration issue and not knowing what the data in each warehouse is.
So from a digital twin perspective, there's huge cost reduction all the way through the operation. From the time you start, once you have your initial digital twin, you start to save and generate ROI on the operation itself. Once it's fully up and running, you have a daily optimization that's going to run, that's going to save you anywhere between 5 to 12%, depending on the operation itself all the way through. Anything that's related to workforce, that's all driven by how well automation and WMS is actually implemented. The digital twin is only act as a beneficiary from these two systems at this point, from a workforce reduction perspective. But keep in mind, the digital twin is not replacing people. It's empowering people to do more and have more time to do more important activities within the organization itself. So instead of just constantly slotting every day, I'm going to let the person who's doing the slotting just validate that the digital twin and the AI are doing what they need to do, and look ahead and start to do other activities within the organization itself that is more critical from an operational point of view. So just always think about it from that perspective as you go forward.
So as you can see, all these three packages give you fantastic return on investment to overcome any challenge that you have in deploying Industry 5.0. So again, we want to thank everyone for coming today. And if you have any more questions, I just want to make sure we answered all the questions in the chat. Are there any more questions out there? Please let us know. Please follow up with us. We sent out an email earlier today. You have my email address. Feel free to contact me, Hosni, Danny, or John at any time. You can find us on LinkedIn. We're pretty prolific there. And please look us up. We really appreciate you coming. Fantastic questions, good dialogue. We will be having a webinar in January. Look out for that. And with that, any closing comments? John, you want to kick us off?
Yeah, I just want to say, what we're doing here is we're using technology now to validate the systems we put together. And in today's environment, you definitely need to be competitive and not be put behind. A lot of people talk about AI in the future, digital twins. It's now, and it's rapidly moving. And I think, it would behoove many of you to get involved with us and let us take a look at your operation and see how we can all help the four of us.
Danny?
The key buzzword is integration. Having integration in multiple platform is essential, because not having the integration creates a broken link and broken link creates invalid data, not inaccurate data. So as you can see, the seamless integration between the digital WMS ERP is crucial.
Hosni?
Yeah, that's same as John and Danny. Basically, digital twin and AI, and specifically AI, is here to stay. We as a team, Jim, myself, Danny, and John, we are actually implementing digital twin and AI, while other companies are just talking about it. We are implementing it today.
Well said. Well, and I want to thank John, Danny, and Hosni for putting together this deck. Fantastic job. Fantastic talk. I look forward to more questions and really enjoy working with all of you guys. And we're a team, and we can solve any environment situation. So please contact us and ask us any question you have. And we look forward to seeing you in future webinars. Thank you and have a great day.
Thank you, Jim.
Thank you, everyone.